Hello everyone, welcome to my YouTube channel. Today we are going to discuss about Retrieval-Augmented Generation, also known as RAG. So let's get started. Let's understand what we are going to capture in this video. First we'll understand how AI model generates content, and then we'll understand what are the limitations of AI models, specifically LLM models. And then we'll see what is Retrieval-Augmented Generation or RAG systems, and then how do they overcome the limitations that AI models had, right? We'll also discuss how RAG works or RAG works, what are the components of that, and then we'll see some applications where we can use RAG. And at last, we'll conclude this video with what we have discussed in this tutorial or video, and then what will be the next steps. Okay, so let's build our intuition by understanding how AI model generate content. First thing is training. So these AI models are trained on huge amount of data. This like GPT is trained on entire Wikipedia, website, books, articles, and the main aim of training is to understand the language patterns and their semantics, right? Now, if we talk about how do they understand the context, so basically the model learns relationship between words and concepts by predicting the next word in the sequence. There are different methodologies involved in that, and I'm not going to talk about that in detail for now. But the most famous architecture here is transformer architecture, which basically applies attention mechanism. And I'm not going to talk about attention, what is attention or and all, but you can understand that given a sequence, let's say we have a sequence, how are you, right? So given a sequence, it attention mechanism weighs the importance of each word, right, in the sequence, right? So for, let's say we can say for how, the most important word will be are than any other word, right? Similarly for or, most important word will be you than any other word, right? So transformer is an architecture that is used to understand the context. And how does it do is it applies a principle called attention mechanism. So attention mechanism is basically tells which word is important given a sequence. In this sequence, how are you? For our most important word is you, right? So this is how model understand the context. Now let's talk about the content generation process. So once user provides a prompt, for this example, you can see I have mentioned what is climate change, right? So this this whole prompt gets divided into tokens first, and there are different methods for dividing it into tokens. If we talk about that, it can be on words based tokens, it can be on subword based, or it can be on character based, right? Again, just to give you an idea, how does it work? If we talk about word based, words can be like what is one word, and then we have is, then we have climate, and so on, right? If I talk about subwords, subwords can be WHA, then T can be a separate subword, is can be a separate subword, CLI, mate can be a separate subword, and so on, right? So if you see, I mean, this subword based tokenization does not make sense to us because we are trained understanding patterns in different manner, right? For model, it completely makes sense. Then you'll see that okay, this sort of tokenization may happen, right? So this is how subword works. And then character level tokenization is very simple. Every character is treated as different tokens. So A will be different token, T will be different token, I will be different token, and S, right? So and so on, right? So this is how tokenization works. Now, after applying the tokenization to this sequence, what happens? We have contextual processing, where model based on its prior understanding tries to analyze this input prompt that we have provided and then understand the pattern out of it, right? So, and at last what happens? It predicts the next word in the sequence given given the input prompt. Okay, so in last section we have seen how AI model generate content, and here we'll see what are the limitations that we might face with AI model implementation or LM model implementation, right? So first thing is lack of real-time knowledge, right? So we've understood that okay, LM models or AI models are trained on huge amount of data. They have access to various articles on which it has been trained on or Wikipedia. However, they do not have access to real-time data, or like they cannot access the current information. For example, if we ask a question to LM model, what is the Apple stock price today, right? So then it does not have access to financial databases or APIs by which it can give us the answer that okay, $110 for say, right? So this is one limitation that you might face with AI models or LLM models. Now, second is hallucination, right? Because this is trained on huge amount of data, which is and the data is pretty generalized in different domains. So it does not have specific informations and may keep on producing same sort of uh, response or incorrect response, right, multiple times. So that is what is called hallucination. Moving on, third thing that may happen or the limitation that you can see is it does not have domain expertise, right? Like, so if you ask a question related to particular domain, like what are the key clauses in the latest data protection regulation update, right? So it again, it does because it does not have access to current data protection regulation documents, it may give you false or incorrect response, right? Okay, so let's understand next point. So no understanding of truth and facts, right? So because LLM models or AI model do not have access to real-time data, they do not understand the facts. So if we ask a question for which they do not know the answers, then they'll try to produce the answer based on what they're trained on, right? So let's say if we ask a question, who won FIFA World Cup 2025, right? And it may produce a result like FIFA World Cup was won by Brazil. So why it is happening? We are still in 2025 and there is no World Cup that has been taken place, right? So we understand that factually this is wrong. But why it may happen? Because it is trained on a data where maximum occurrence of winner is Brazil, right? Maximum occurrence of winner is Brazil, right? So that is one thing that may happen with the AI model LLM models. Now let's understand ethical and uh, bias issues, right? So let's take an example. So if our model is trained on data that is biased, and then we ask a question like who who is better cooking, right? And it may produce that generally women are better in cooking, right? So that can be a bias in some scenarios. It totally depends on what sort of data it is trained on, but yeah, sometimes it may produce the results that are ethically not right or biased towards certain people category. So this is it about, right? So these are basically some limitations that we might face in AI models. Next, we'll see RAG or retrieval augmented generation, which overcomes these limitations, and then we'll see how do it it applies principles to overcome these limitations of LLM models or AI models. Till now, we have seen how AI model generates content, and then we've seen what are the limitations of AI models. In this section, we'll see what is retrieval augmented generation or RAG, and then how do they overcome the issues that we have with AI models or LM models, right? So RAG or retrieval augmented generation is a technique that combines the power of LLM and information retrieval system, right? And So if you have observed, it is combination of two things. One is LLM and the second one is information retrieval system. And then the aim is to enhance the accuracy and relevance of generated response to user query, right? So the limitations that we had in LLMs or AI models, to overcome that, we use or we combine LLMs with information retrieval system, and that is what RAG is. I think and it has two main components. One is retriever, which basically fetches the relevant information from data sources like database, external websites, documents, or PDFs, or anything, right? Any data source you can say, and then passes this information to models, which is nothing but our LLM model like ChatGPT or DeepSeek, and then that model combines that result that has been passed from retriever and combines it with query that user has asked to produce the final response. And this process is called as generator process, right? So generator is nothing but an LLM model which takes input from input as user query and retriever information system, which takes input as user query and the information that has been fetched from relevant data sources by retriever, right? And combines it and produces a result, right? So this is how, in a nutshell, retriever augment generation works. Next, we'll see why do we need RAG or RAG systems, and how do they overcome the limitation that we have seen in AI models or LLM models. Okay, so till now we have understood what is RAG and the component of RAG, like information retrieval system or retriever, and then generator, which is nothing but an LLM, right? Now let's understand how it overcomes the limitation that we have had with LLMs or AI models. So for first example, if you remember, we had a query, what was the Apple stock price yesterday, right? And because LLM did not have access to financial database, it could not produce the actual result. And how RAG works is it has access to financial databases or using APIs that can extract the information, and that information is passed to LLM to generate the response, right? Similarly, because we are providing specific information, it reduces the hallucination in the process, right? Also, like for domain-specific task, I think if you remember, we have taken an example of what is the latest clause for data protection regulation, and again, our retriever will have access to specific legal documents and regulation to concise the summary and then give it back to LLM where it produces the results, right? Number four, I think one of the most important point is data privacy and issues, right? So let's understand this with an example. If we if you've seen, ChatGPT also has an option where you can upload your document and then you can query to that document, right? But just imagine in real-time scenarios, any company, will they be interested or comfortable sharing their private data with ChatGPT, or will be comfortable sending it on cloud? I don't think so, right? So, so it is better to implement RAG system locally, and then user can use that, right? So that data privacy is one of the major concerns. To solve that or to cater that issue, we can use RAG system. Okay, so I think that's it for this section. We'll see how RAG works or retrieval augmented generation works in the next section. Okay, so let's discuss how RAG works. It has three main steps. One is retrieval, second is augmentation and generation. In retrieval, information retrieval system searches for knowledge base or relevant documents based on user queries, and then the response or the results that it has, like the documents that it has received, are passed in augmentation phase to generator, which is nothing but a large language model. And then large language model combines that with the user query to produce response. I think let's understand this with this diagram, right? I think that is pretty self-explanatory, but just give me a minute. So if you see, this is user questions. Smart search is nothing but our information retrieval system. I'm typing it as IRS. It goes to our knowledge base, which can be anything. It can be an API, it can be a document, it can be a database. So this is our knowledge base. It queries that knowledge base, gets a response, and then that response is sent back with question to LLM, and LLM combines that and produces the result, right? So this is how the overall RAG process works. User questions to query. In backend, there are different steps involved. So if I explain about a bit more technical and the implementation that we'll see in our practical session. So what happens? User sends the query that gets converted into chunks, and then we have embedding because our model does not understand text. So embedding converts that to vectors, and then these vectors, like this will be our query vector, and then we check related documents in our knowledge base using some sort of similarity mechanism. We can use cosine similarity, dot product, and all. I hope you are aware about that. Otherwise, we'll discuss this in upcoming sessions when we discuss our practical implementation, right? So, based on the similarity, related documents are fetched. Related documents are fetched, and then these documents are passed to LLM. LLM, and then LLM combines those with query query input plus document that we have received to generate the final response, right? So this is how the whole process works, right? I hope it made sense. If you have any questions related to that, you can always drop a note and comment. So yeah, this is how RAG works. In last section, we have seen how RAG works or RAG works, and we've seen basic architecture of that, where we have user queries that, based on the user query, our information retrieval system searches for relevant information in from knowledge base, and then that is being passed to LLM to produce the response, right? Now, what are the applications uh, that you can build with RAG? So, some examples of applications that we can build using RAG. One is chatbots, real-world chatbots that has access to current to correct informations. It can be implemented in companies, like for company policy related, right? Company policy related. We can have a smart Q&A system that can answer all the questions related to any specific domain, and then it can also be used for creating content or factual contents, I'll say, like with access to current data. So these are some applications that we can build using RAG, and in next section we'll see what we've covered in this, right? Okay, so let's see what we have covered. So we've we've seen how AI model generate content. We've seen the training, that large language models are trained on huge amount of data, and it understands the context of data with defining or understanding relationship between words, right? And then we've seen that, okay, based on user prompt gets converted or broken into tokens, and then based on previous understanding, model understand the context, and then it produces a word at a time as result, right? And then we've seen what are the limitations of AI models, like lack of factual accuracy, hallucination, domain adaptability, and also data privacy sometimes. Then we've seen what is retrieval-augmented generation and how it overcomes the issues that we have, or limitation that we had with AI model. So it has basically two components, retriever and generator. Retriever access the up-to-date informations, passes it as augmentation to our generator, which is nothing but a LLM model that combines user query with the response or information that it has received from retriever system to produce the the response, right? We've also taken or seen some examples where we understood how RAG overcomes the limitation of AI models. And then at last, we've seen some applications like chatbots, Q&A systems, and it can be used for content creation as well, right? So, yep, this is what we've covered. And in the next set of sections or videos, I'll be covering practical implementation of RAG using LangChain and also some important questions that you may encounter when you go for an interview related to RAG or LangChain.